Okay, friends, so today we are with the content based recommender system. This is on demand video. This is the part 3 which we will be building, and this is the recommender system based on keywords, crew, cast, and genre. Genre, yeah, genre. This is how we pronounce it. Okay, so before you start this video, make sure that you have seen the part 1 and part 2 of this recommender system, which I'm working with the same CSV file, that is credit.csv, and you can get this file from going on this dataset like tmbd of here. You can go and access this file on Kaggle tmbd dataset, wherein you will also get the CSV file which we are working, credits.csv, and another file is movies.csv. So I'll just show you how does this look. So have a quick review of this. In the first file we have got some around 4 columns and 4000 something rows, and in the second movies.csv we've got certain around like 4000 rows and 20 columns, and I have just merged it also in df2. Okay, and I'll be working with this df2. So I have merged this on id, and so that I can get the title, cast, crew as in a single data frame. Okay, so please make sure that you go in and watch the previous videos of movie recommender system part 1 and 2. Links will be provided also in the end card. You can see that, right? Okay, so assuming that you've gone through how we have built a recommender system based on the overview, that is the most popular movies in the overview column, and I am also assuming that you know how to work with like what is the difference between like why are we using this cosine similarity, and how we have really trained the model and fit all these things and transformed. We have used this tfid vectorizer, right, so that we can count the frequencies, and we have used actually inverse tfid. So not investing much time in that, I would just simply go on to this video. So what we did was had used only the overview column to make recommendations. The overview only meant that you have the similar plot. So Dark Knight Rises have the same plot as the Batman Forever, similar plot, so this recommendation were based on the description, the similar plot. So I just got the first 10 recommendations on the movies like JFK if I want to watch. So these are the recommendations. Now what we want is we want to further upgrade our content based system, recommender system, so that we can get movies as per the cast or the keywords or the crew, like the director or editor or the genre. So what I do is now I have to use the literal evaluate for this. Now before I jump into and explain you why are we doing this, you first need to see the data set. Okay, so I will just show you the data, the unclean data which we were working previously, because I have not disturbed this file, I just kept it like that. Now can you see this keyword? You have this in a form of a dictionary, and you've got various things here, keyword id 1463, then you've got some colons, semicolons. So there's a lot of error when you parse this data, these columns and rows. Even in the genre you have got this, you've got it in keywords, you've also got it in the cast, but I have to use this cast. Now to make things more simpler for you, I will take you to the data set itself and show you how does this look. This is the cast. Can you see? This is huge, this is long. Can you see this? Okay, so now I will take you to, all right, this is the cast of Avatar, and can you see this is quite long? Now what I want is I just want to clean this data. Okay, that's what I'm doing it here. So what I'm using here is, okay, just bear with me when I just scroll these things. I'll just stop where we are doing it. So now what I do is I use this literal evaluate, right? From AST I will use that so that I can clean my data and I get a very simplified list. So that is what I'm doing. I'm creating a list of list name features. In this I am just storing this cast, crew, keywords and genre because I'm using this thing. Okay, you can also use like cast, crew, keywords if you don't want genre. You can also use cast and crew, depends upon how do you do it. So I just wanted to make it more diverse, so I use these four columns. Okay, right, now I create a for loop. In that what I do is I just use these features and I apply these literal values, and it will go and iterate in all these the columns and will really make it very simple for us. So if I just can show you a little bit about this. So this is the website. I'll provide the link in the description box. Do not worry about that. You will get it. So this is what happens here, that you've got this ID, and what happens is that you get it clean, as you can see here, only in the form of a list. That's what we are making it. Now what we do is, I have not written here because it has been written in the website. It would be redundant. Now what you do is you make a function. So now we'll make 2-3 functions so that things will be more clear. What I'm doing is I'm just using the director's name from the crew feature. Now in this, why only director's name? Because in this crew you've got various names, like under the job you've got director, you've got editor, you've got screenplayer. So I'll show you how does this look. First understand the data which you're working in. This is, I think, cast and crew. Okay, this is the crew data which I was talking about. Now you see you have this as department. The key, it is in the dictionary format, right? So the key and the value. Now you see here the key is job and it is editor. You've also got one as, now if I show you this one, cast, and you see this job as, okay, fine, director of photography. You've also got only director, right? Yeah, you can see original music composer. There are various jobs. I just want director. I don't want all these things. Okay, that's why I have, see, you've got screenplay also. What I want is, I just want director. Okay, so I have used this as a function, and in that I'm saying that I just want a list of directors, so please give me that. And you return np.nan if you do not find any director in that list. Okay, next, now if you're not fascinated with direction, if you want some specific thing, you can mention here. Okay, depends on what you want from the data, what value you want to extract. Next thing is, what I do is, now since I also have to use like cast, crew and keyword, now I will extract all crucial information from these 3 columns. What would I do is, okay, sorry, crew is done, cast, keyword and genre. So I will use a single function for all these things. Now I will make a function called get list. Okay, and then I will go in for if and condition. Why I am using this condition? Understand the logic, you can get the code. Okay, I will provide the github link also, and it is also uploaded on the website. Now why, now and again I will go walk you through this data set of cast, crew, so that you understand this thing. What I do is, now you can see this genre. Okay, now I have, as you see here, name. It is action, it is also adventure, and it is also fantasy and science fiction. Can you see this? Okay, next, if I explore, it is adventure, fantasy, action. Next, it is action, adventure, crime. So I've got various genre. The nature of the movies, they are of different types. Now this was genre. Now I will take you to the keyword of it. The keyword is culture clash, future, space war, space colony, society. I think it is Avatar. Okay. All right, and then you've got ocean. Okay, where is it? And then you've got this ocean, drug abuse, exotic island. This is Pirates of Caribbean. Since I've done it so many times, I also remember the name. Like, see, Avatar, Pirates of Caribbean. Okay. So you can just understand from the keywords also which movie is there. Ocean, drug abuse, exotic island. So if you want to watch a movie on oceans, you can just give it the keyword and the movies would be retrieved, right? The second keyword is spy, based on novel, secret agent, sequel and stuff like that. Now you understand that how we have got the data, and now we have to extract these keywords from this, and that's why we are making a function with a condition. Okay, let me also tell you one more thing which we are using, and that is, I think, okay, we're using genre, keyword and cast. So the cast is, since I have not merged it here, I can tell you the cast here. Now can you see this cast? It's Jake. Okay, then you've got Sam, and you've got Kelson, Dragon, Gunship, Gunner. I don't know what all cast you have. Then again you've got Captain Jack Sparrow, then you've got Johnny Depp. There's so many cast here. Okay, so as you can see here, there's so many cast. right? I cannot use all the cast here. So what I do is I will use only the main cast. Okay, so that is how I'm extracting the data from this. And so that is the function to extract the meaningful data from this. So what I do is I create a list of this. Again, I use if is instance. If it is present in that list, then you return that. And another condition is that if the length of name is greater than 3, then you return me only 3. Okay, 3, that means if the cast is, if I've shown you the genre of this, or okay, if I've shown you the, okay, I'll show you the genre. If I have shown you this thing, then only 3 will be returned, that is action, adventure and fantasy. That is what I want. If the length is greater than 3, it will return only 3. If it is greater, yeah, if it is 3, then it will return me 3. That is what the function says. Similarly, this will be applied to all these columns like keywords, genre and the cast. Okay, now I have made this function. Now I want to apply this function. Okay, and what I do is I will define this director, cast, genre and keywords into a suitable format. So how would I do it? I just made this df2 director, and in that in this column what I want is I want to apply this director which I have created here, this function get director. Okay, only the directors would be concatenated here, as you can see. Okay, and what I do is for the features I create another column for features, wherein I would get this cast, keyword and genre, the other 3 filters, and I would apply get list, my next function in this. Okay, so when I just call this, when I want to see the first 5 entries, I can see the title, I can see the cast. You can see here how clean is this list, with no dictionary format, key value, or with semicolon, colons and different things which could have hindered and thrown a lot of errors. So we get here cast, director, keywords, genre in a very clean format, right? And so now the search would be really easy for us. That is why we have to invest a lot of time in cleaning the data. Okay, now what you do is, again, we have to clean a data, because now it is quite possible that the same cast, that means the actors might have the same first name and the last name might differ, but you want like the name of your particular actor, like Johnny Depp. You've also got many actors with the name Johnny with different second name. So what happens here is that we will clean this data. Again, I will create a function for that, right? And in that, what we'll do is we will replace this thing, capital caps lock, the first uppercase with the lowercase, and also the strings, any spaces in the string would be removed. Okay, and why am I doing it? Because when I will be using the similarity or the cosine similarity, these will not be the same name will be treated as differently. That means Johnny Depp and another Johnny would be taken as a separate actor. Okay, they won't be confused with. So now what I do is I will create this function clean data, and then I create an if else. And for the first thing, I will replace the uppercase with the lowercase, and in the second one I'm just replacing the empty string, that means the space, with simple this thing. Okay, so that there's no space in the string. That's what I'm doing it here. Then what I do is I will apply this clean data function. Again, I did the same thing. In this feature, in this list, the four columns which I have taken, I will just apply this data, clean data, the function. And when it has been applied, what I do is, okay, I just want to show you something more here. Extracting information has been done, cleaning the data has been done. Now we are coming to creating a metadata. We have just done a lot of work here. So, okay, this would not work. So now we are just creating the metadata here. What do you mean by metadata here is that I will use this metadata in extracting the information. That means for the content base, I need this metadata. So I create some function called soup here. In this, I will just join my keyword. Okay, I will join the cast, director and genre here. right? Now this metadata will help me to extract or make recommendations, and that is what I'm doing here with this metadata. I just define a function and I apply this in this column, in this row, right? df soup, and here what I apply it. Now after making this metadata, what I do is I will use the count vectorizer instead of ifd. Previously we have used tfid, inverse tfid. Now I'm just using count vectorizer. Now there's a difference between the two. I hope you can go ahead with the difference, but just to give you a basic intuitive knowledge about it, count vectorizer will simply count the number of times the actor has acted in a movie, which is fine for me if it is 1 or 2 or 3, and I don't have to devalue if the actor has acted just once or twice, right? So what I'm doing here is that the presence of actor, I will not downweight. I just need the count. That's all. And what the TFID was doing is it penalizes them if it if it occurs most for the most of the time, because it is also considering the overall document weightage, and it gives equal weightage to the word. So that is what not we are looking for here. We are just looking for the occurrences. So that is what I'm doing here. So we use this count vectorizer here, and what you do is you stop word again, you count the stop words, and then I will create a matrix called count matrix here, and fit transform this df to soup, this one what we have applied it here. Okay, the entire metadata will be concatenated or transfitted here, right? So that we can use this count matrix for our cosine similarity. Now we will again do the same thing which we did in the previous content building, this thing, recommender system. We have imported this cosine similarity, and cosine similarity 2, I'll make an object wherein I will store this count matrix and count matrix again. And now see, this thing has been done previously. I've explained you in the previous videos also, so I'll just go through it in a little faster. And if you have a problem, please do comment in the description box that you've not understood. I will try to make you understand then what you do is you reset the index in the data frame and you construct reverse mapping as before. That's what we've done. I'm just repeating those steps, right? So just do the same thing. You reset the index, and what you do is index would be the title X, and then we will start making the recommendations. Okay, so okay, so I will make recommendations. I think this is just the last part of it. Make recommendations based on what we have made on the cosine similarity. I will be using this cosine similarity to object, so that it just maps in all these genre and our soup and give us a recommendation based on more data that we have made available to the recommender system. Now suppose I give the recommendation of JFK movie and I use this cosine similarity, and now you see the first 10 recommendations what it is giving me: the Zero Dark Thirsty, Criminal, and so on. Okay, you just name your movie and get the recommendations. Now this I also want to show you one difference in this. When you're seeing this JFK here, you see the movies that has been recommended based on a few parameters, and that those parameters are, as you know, that is crew, that means the director. Okay, so I'll just write the director. It is the cast, that is the actors. It is also the genre, right, and also the keywords. So these recommendations are made based on all these four things that we have made, and that's what we were doing since the previous part. So I'm getting the recommendations based on these metadata. Okay, right. Now the next movie I want is like Godfather, the similar movies based on all these things. This will give me Godfather part 2, part 1, part 3, part 2, and so on. Now I just want to show you one more thing. Just see this Avatar movie. Okay, and you see here Clash of Titan, The Mummy, The Monkey King 2. And I would want you to show you the difference here. Why I'm taking so much of time here is that because I want to show you here the movie Avatar, and based on the overview which we have done it in the previous video, it was when I made the recommendation of Avatar, it was giving me different movies like Apollo 18, The American, The Matrix, and so on. But here it is completely different when I make recommendation with Avatar here. it is the Clash of Titans, the Mummy. So based on your content, based on your search you are giving, you are getting different movies. Okay, so this is the difference when you are playing with different keywords, playing with different you know columns. Now one more thing which you can add is the production. Now suppose if I don't if I'm more fond of Warner Brothers or Disney, Walt Disney. So what I do is I have this called a column called production companies. Here, the production companies, and you can see here that you've got Columbia Pictures. Now suppose I want all the movies from Columbia Pictures. What I can do is, again, I can define a function and I can use this production companies if, and I can create a condition if it is from Columbia Pictures or it is from Walt Disney, then you return, right? Just like as did in the case of director. I will do the same thing here for production company. So you can play around with different columns and different features to make your own recommender system. So this was the third part of the recommender system, guys. Do not get confused, it is very easy. I will provide all the code and everything. You don't have to worry, just understand the concept what we are doing here. This is the third part, and another one is the collaborative filtering based movie recommender system. So if you want that, just give me, mention it in the comment section that you want the part for the collaborative filtering so that I can come up with it. It might take a few days, but yes, I can come up with that. Bear with me, and if you have not subscribed the channel, guys, please do subscribe, like and comment. And I hope you would really benefit from this recommender system, because they are really very interesting to work on, provided you understand the data, because the data is very complex. As you can see, you've got some 4,000 rows and columns, and the data is very unclean. You have to clean the data, and the basic I have already provided you. Okay, how do you do it? How do you remove the literals and make it really clean? So this will really help you in moving ahead. And yes, please go and watch the second video, because you won't understand if you what I have done, how this title X is coming, and so on and so forth. So please make sure that you go ahead and see the first two part of it, and also go and visit the site, wherein you can just have a quick glimpse and the details of what has been done, why is it being done, and the details of it. Okay, so yes, and that's it for this video. And thanks for watching. Please comment, subscribe. Again, I'm saying that because I need your support. And okay, that's it. Thank you.